Okay, done.
Hello everyone to the virtual seminar in economic theory. Today we're happy to have Yingni Guo, who will present the paper Robust Monopoly Regulation with Aaron Smaya. And we also have two guest panelists, Dirk Bergman and Daniel Garrett. So the format is going to be 6 minutes presentation, and at the end we're going to open for questions for 15 minutes for a Q&A. So during the talk, you can post comments and questions on the Q&A section, and we will try to ask them during the talk. Also, Aaron might answer them on the spot there. And for the questions that we don't ask them, we can ask them at the end. So next week, we will have Bart Hastad presenting the conservation multiplier, and a guest panelist who is going to be Tim Besley. So for this hour, welcome Yingni, and the floor is yours.
Thank you very much. Thank you for having me, and thank everyone for coming. This is joint work with Aaron Smaya, and he's also with us today. The paper is about monopoly regulation. So we all know that monopoly is notoriously challenging. Right? A monopoly firm has the market power to set its price above that in an oligopoly or competitive market. For instance, this QJE paper by Cooper and his co-authors shows that prices at monopoly hospitals are 12% higher than those in markets with 4 or 5 rivals. So this picture shows the price premium for individual procedures. Okay. Now, in order to protect consumers, a regulator may want to constrain a monopoly firm's price. However, a price-constrained firm may fail to obtain enough revenue to cover its fixed cost, so it may end up not producing at all. Okay, so the regulator must balance the need to protect consumers and the need to not distort production. Okay. Now, this challenge could be solved very, very easily if the regulator had complete information about the industry he regulates. So he would ask the firm to produce the efficient level and to price at the marginal cost at that efficient level. He then subsidizes the firm for all of its other costs. Right? So in this case, the regulator would make sure that the maximum surplus is generated and all the surplus goes to the consumer. Okay. In reality, the regulator typically has limited information about the cost or demand functions of the firm. So what shall this regulator do when he knows much less about the industry than the firm does? If the regulator demands robustness and he wants a policy that works fairly well in all the circumstances, what shall this policy look like? Okay, so in this paper, we address this classic problem of monopoly regulation using a non-Bayesian approach. So the regulator's payoff is a weighted sum of consumer surplus and the firm's profit. The parameter phi is the weight that the regulator puts on the firm's profit. It goes from 0 to 1. Okay, phi stands for firm. Okay. Our regulator can regulate the firm's price and the quantity. He can give a subsidy to the firm or charge a tax from it. So in other words, he has all kinds of instruments he can use. Given a policy, the firm would choose a price and a quantity to maximize its own profit. Now, in this case, we can calculate the loss to the regulator, which is the difference between what he could have gotten if he had complete information about the industry and what he actually gets given his policy. Right? So this is called the regulator's regret. We can think about this regret as the money left on the table due to the regulator's incomplete information. Now, we focus on situations in which the regulator has very little information and he chooses a policy to minimize his worst case regret. So the regulator's worst case regret is his highest regret across all the possible demand and cost scenarios. The optimal policy minimizes this worst case regret. Any questions so far? Okay, this is just a preview. I would go over the model in detail in a few minutes. So to preview what we have found, I would begin with two extreme cases of the regulator's payoff. So at one extreme, the regulator puts zero weight on the firm's profit. So his payoff is simply consumer surplus. He wants to maximize consumers' welfare. Now, in this case, we show that the optimal policy is simply to impose a price cap. Okay. Now, a price cap bounds how much consumer surplus the firm can extract. Consumers benefit from a lower price in that case. On the other hand, a price cap might discourage a firm which should have produced from producing, right? So because it constrains the firm's revenue. So in that case, the consumers will lose due to the firm's underproduction. The optimal price cap would balance the gain from a lower price for the consumers and the loss from underproduction. So that's the one extreme. So at the other extreme, the regulator puts a weight 1 on the firm's profit. So his payoff is consumer surplus plus firm's profit. In this case, the regulator simply wants to maximize efficiency. He wants the firm to produce as efficiently as possible. So we all know that if the firm is not regulated, the monopoly firm tends to underproduce. Right? The monopoly firm tends to supply less than efficient level. So in this case, the regulator wants to encourage more production by subsidizing the firm. Okay. However, subsidy might encourage a firm which should have not produced to supply the market. So in this case, the regulator must balance the loss from underproduction and the loss from overproduction. Now, we show in this case that the optimal policy is a piece rate subsidy. So this piece rate subsidy effectively increases the firm's selling price, so the firm is willing to produce more. On the other hand, the regulator would put a cap on the total subsidy he is willing to offer so that he doesn't induce too much overproduction. Now, for everything in between, the optimal policy is a combination of the price cap, the piece rate subsidy, and a cap on the total subsidy the regulator is willing to offer. So this optimal policy would balance three objectives of our regulator. So our regulator wants to deliver more surplus to the consumers. That's the first objective. He wants to mitigate underproduction, which is intrinsic in a monopoly problem. He also wants to mitigate potential overproduction from the monopoly. So this is a very quick overview of our result. Before I move to the model, I want to discuss the closest literature. So we contribute to this literature on monopoly reputation. Armstrong and Sappington is a recent survey on this area. The closest papers are Baron Meyerson, Louis Sappington, and Armstrong. They assume that the firm has private information about its cost function or demand function. Right? So the regulator in this case has a prior belief over a cost parameter or demand parameter, and he wants to minimize the expected regret. We differ in how we address in our approach to uncertainty. Our regulator wants to minimize the worst case regret. We are also related to the growing literature on robust mechanism design. We are closely related to the papers which are also about minimizing the worst case regret. So this paper by Hewitt and Shapiro is about the moral hazard problem. Bergman and Schnack are about monopoly pricing. Mansky offers a very nice discussion on vaccination under worst case regret. So this is very relevant for the ongoing pandemic. And Bevy and Cotron is about contest design under worst case regret. So we differ in the sense that we look at the monopoly regulation. we are also closely related to the paper by Daniel, which is about, this paper is about cost-based procurement when there is a monopoly supplier. Okay. So lastly, we contribute to the delegation literature by providing a foundation to not using money. So we will show in the paper that when the regulator cares sufficiently more about consumers, or when the consumers are sufficiently homogeneous, it's optimal to just impose a price cap. So to the best of our knowledge, this is the first paper that shows that not using money is optimal, even if the regulator and the firm can make transfers to each other. Okay, so this concludes the introduction. I saw that there are quite a few questions in the chat or Q&A. So I'm not going to, let me see. Okay, good. So in that case, I'll leave the host to raise an alarm when a question arises. Okay. Any questions?
There was one question about motivation for looking at min impacts regret, but I think you're going to talk about that probably.
Yes. So I would also talk about that in the conclusion about why we look at this particular approach. Right. So actually, just to give I want to maybe talk a little bit about why we are looking at we are using a non-Bayesian approach instead of a Bayesian approach. So there are two observations made Armstrong and Seppington about the Bayesian approach in addressing monopoly regulation. The first observation is that this is a setting in which typically the information asymmetry is very, very pronounced. So it's not clear how to formulate a prior belief. Right? So that's one reason why we're looking at a non-Bayesian approach. The second reason is that multi-dimensional screening is typically very difficult to solve in the Bayesian setting. So as you will see in our model, in this case, the information asymmetry is infinite dimensional. So we're able to solve this type of multi-dimensional screening problem. We are able to deliver some intuition about this problem. Okay, and I will also talk later in the conclusion about why we choose this particular way of we choose worst case regret instead of other robust mechanism design approach. Now let's go to the model. So this the model is a very, very standard monopoly regulation problem, and everything except the last slide is standard, so you can just pay half attention. Okay, now we have a monopoly firm and a mass one of consumers. The demand function of the firm is given by V, which is mapping from the unit interval to 0 V upper bar. So V bar is the highest value that a consumer can have for the firm's product. Okay. Now, the firm can only choose a quantity Q and a price P if this quantity Q and P is below the demand function. So if P is smaller than VQ, we call these quantity price pairs feasible. Okay. Now the cost function of the firm is given by capital C, and it's weekly positive and weekly increasing. So producing more involves potentially more cost. Now, given a demand function V and a cost function C, we can calculate the total surplus when the firm produces a quantity Q. This is the total value to the consumers up to Q minus the cost of producing Q. So that's the surplus if the firm chooses to produce Q. And the maximum total surplus is to take the maximum over Q, and we use optimal OPT to represent the maximum total surplus in this market. Now, if the firm chooses to produce Q, the distortion in terms of production is the difference between the maximum total surplus and the realized total surplus given this quantity Q. Okay. Now let's look at two demand and cost scenarios that we will use in the talk frequently. So this is the first example. So this blue line, questions?
Just sorry. Would you mind guys going back one slide?
Yes.
So the formulation of consumer surplus, the V of Z, is quite general and also very abstract. So you might wonder which model sort of, say, nonlinear pricing could be accommodated by this formulation. You know, is the Mask and Riley nonlinear pricing part of it? Is the Musa-Rosen model part of it? Are there restrictions that are implied by these formulations, or just to get a sense of
I see.
what choices you have made with this formulation?
So we are not talking about Musa-Rosen. At this, we're talking about, you can think about it's like a monopoly posting a price on the market. So it's very similar to your paper with Kao.
I see. So it's just it's essentially unit demand of consumers.
Yes, it's there is a unit of consumers, and then the firm would choose a price and the quantity.
Great.
And the price is the same for every consumers.
Great.
Okay. Yeah. Thank you. Yeah.
So you could, I mean, you may want to talk about this in the end, or you will. I guess, you know, the problem of regulation, as Baron and Myers so formulated, is often posed for more general nonlinear problems. And so I guess I'm curious to know whether you have thought about extending it, and then what the corresponding results would be. Mm-hmm.
Yeah, that's actually a very, very good question. Yes, we haven't moved beyond this framework, but we should definitely think about that. Yeah. What happens when, for example, we talking about regulating a Musa-Rosen monopoly seller in this setting? Yeah, we should think about it. Yes, thank you. But so far, we're thinking about the simplest one, which is closer to the Baron-Meyerson, yeah, the linear pricing framework. So yes, let's go back to the first demand function. This is just an example. So in this demand function, the first 2/3 of the consumers have the highest valuation, V upper bar, and starting from 2/3, we have the unit elastic demand. So the Z's consumers value is 2/3 V bar over Z. So in this market, the cost of production is 0. So now it's, in terms of socially optimal production, the firm should produce 1 unit of good, but also the firm finds it optimal to just produce 2/3 and to set the price at a V upper bar. So if the firm does that, the distortion is this whole area of blue surplus that is lost. So in this case, the distortion is the area of this blue region. And we say that the firm underproduces because 2/3 is smaller than 1. Okay, so now let's look at another example. So in this example, the first half of consumers have value half V bar. So the total consumer value in this market is 1/4 V bar, right? And there is a huge cost of production. The fixed cost of production is 1/3 V upper bar. So in this case, the firm should not produce because the cost is just too high. If the firm chooses to produce 1/2, then the firm actually overproduces. The distortion is a 0 minus a negative surplus that is generated. It's also, distortion is positive. So the distortion is always positive. And in this case, we say that the firm overproduces. Now, these are the 2 examples we will use later on in the talk. So now let's introduce regulation policy. So a regulation policy is given by rho. So if the regulation policy, so this policy is saying that if the firm sells Q units at price P, then it receives a revenue of rho as a function of Q and P. So this rho is the total revenue that the firm receives from both the market and the regulator, right? Now, if rho QP is greater than QP at some QP, it means that the firm receives a subsidy of rho QP minus QP from the regulator and receive QP from the marketplace. Now, if rho QP is equal to QP for every Q and every P, this firm is essentially not regulated. We just leave it unregulated in that case. I want to give a few examples of regulation policies. So we also allow the firm to stay out of the business with a profit of 0. Okay, so this is the participation constraint. Now, the first policy I want to talk about is a price cap, K. So the regulator can tell the firm, you cannot get more than K per unit. So in this case, if the firm charges a price below K, his revenue is QP. If he charges the price above K, his revenue is Q times K, right? So that's a price cap at K. A second regulation policy is a lump sum subsidy. So we say that maybe the regulator wants to encourage more production, so he can tell the firm, if we produce more than Q tilde, I would give you a lump sum subsidy of S. So in this case, rho QP is equal to QP if Q is smaller than Q tilde, is equal to QP plus S if Q is greater than Q tilde. Okay. Now the last example is a proportional tax. So this is used in China towards the state-owned monopolies, right? So in this case, the firm would just pay a fraction of its revenue to the regulator. So the revenue that the firm gets from QP is 1 minus tau times QP for some tau. So today we are going to show that these lump sum subsidies and proportional taxes are never optimal. So we will show that the optimal instruments are price cap, piece rate subsidy, and a cap on the total subsidy. Okay. Now, so given a policy rho, a demand V, and a cost C, if the firm sells Q units at price P, the firm's profit is the revenue rho minus the cost of production. The consumer surplus is the total surplus for consumer up to Q minus the revenue rho. So basically, we're saying that any subsidy to the firm is paid by consumers through their taxes, and any tax from the firm goes to the consumers as a subsidy for the consumers. Okay, so this is also standard. Now, we say that QP is the best response to the demand V and the cost C of the regulation policy rho if it maximizes the firm's profit among all the feasible QP pair that the firm can choose. The regulator's payoff is a weighted sum of consumer surplus and firm's profit. So phi is a weight for the firm's profit. Now, given this framework, the first claim we want to make is that if the regulator actually knew the demand and cost function, then he can choose a policy such that his payoff is exactly equal to the optimal or the maximum total surplus. So suppose that the regulator knows demand and cost, then the optimal payoff the regulator can get is equal to the optimal or the maximum total surplus. So the regulator would do something very simple. He would calculate the socially optimal quantity. He would tell the firm that if you produce Q star and you charge a price at the marginal cost, then the revenue you would receive exactly covers your cost. I can even give you epsilon more here to induce strict obedience. Now, if you do anything other than this, the revenue is equal to 0. So the firm is willing to do the socially optimal thing, and all the surplus goes to the consumer. One thing I want to note is that this complete information payoff for the regulator is independent of the weight he puts on the firm's profit. Essentially, he generates the maximum surplus, and all of them goes to the consumer. So phi doesn't affect the complete information payoff. Now, given this complete information payoff, we can calculate the regret of the firm, fix a policy rho, a demand V, and a cost C. Now, the regret of the firm, if the firm chooses Q and P to maximize its profit, the regret of the firm is, regret of the regulator is the complete information payoff of the regulator minus the incomplete information payoff. So the complete information payoff is the maximum total surplus, and the incomplete information is weighted sum of consumer surplus and the firm's profit. So we simplify it a little bit, and by adding 1 minus phi times firm's profit inside and outside these parentheses, eventually we can represent the regret using two very intuitive terms. So the regret is a sum of distortion and a weighted fraction of firm's profit. So this distortion represents the regulator's efficiency objective. He wants the firm to produce as efficiently as possible. Whenever there is a distortion, he has some regret. Okay. he also wants all the surplus to go to the consumer. So this second part represents the redistribution objective of the regulator. Whenever there is a firm's profit, he suffers 1 minus 5, which is decreasing in the weight he puts on the firm's profit. Now, as we said before, the regulator's problem is to choose a policy to minimize the worst case regret. The worst case regret is across all the possible demand and cost scenario. And the maximum is over all the VC. For the talk, we assume that the firm breaks the ties against the regulator, but it doesn't matter, this assumption. And the minimization is over all the policy realm. Okay. So in the paper, we actually look at what happens if the demand and cost function lives in a particular set. But for now, we look at the most general case. Suppose that any cost is possible and any demand is possible as long as the maximum value is below V bar. And if you're interested, we can you can look at the paper for the extension. Okay. Any questions so far?
So one question I have is the restrictions on row. A bit in the paper, I think. But is there any? To what extent is there a loss of generality in restricting attention to policies of this class?
So there are a few things like I know it's without loss, right? So here we are not allowing for communication. So we don't allow the firm to report the types and report the demand and cost, and then we design policies. So that's without loss by taxation principle. So the other thing we can think about randomization. So we're not looking at a randomized policy. We know that if phi is equal to 0, it's without loss, but if phi is positive, then by randomizing, the regulator can do better. But in this paper, we're looking at the case that the regulator has to lay out a policy first, and then the nature would choose the worst case VC.
If you say that the regulator can do better with randomization, what is the source of that? Is that hedging the ambiguity, or is that about the agent's incentives, or it could be either?
So basically, it's saying that the nature, the adversary is choosing a VC without knowing the exact policy that is implemented. So that would benefit the regulator. That's the idea. Thank you. Okay. So
a small clarification question. So maybe I missed it. Are you assuming that the monopolist knows V?
Yes, we are assuming that the monopoly firm knows exactly V and C. Yeah. So he's choosing. He observes the V and C. He observes the policy and he chooses QP to maximize his profit. Yes. Thank you. Yeah. Okay. So let's move to the main result. So our main result has two parts. First of all, we are going to show that no matter what policy the regulator chooses, the worst case regret is at least a certain level. Okay, so this is a lower bound on the worst case regret. And in the second part, we show that our policy exactly achieves this lower bound. So this shows that our policy is optimal. And we are going to, for the first part, we are going to have two results. First of all, I'm going to give you a lower bound on the worst case regret to build some intuition. And in the second step, I'm going to give you the tight lower bound, which is the lower bound we are going to use. Okay, so let's first look at what could happen if the regulator just impose a price cap. Okay, so this part of the discussion is simply for intuition building. So suppose the regulator tells the firm, okay, you are not allowed to price above this K, price cap K. Okay. Now, how is this going to affect the worst case regret of the regulator? We look at the first scenario here. So this is a scenario in which every consumer has the highest possible valuation V upper bound. So you can think about this is the valuation for housing, for the vaccine of the COVID, and everyone values this good at a V upper bar. Now, the cost of production is actually 0. So there is no cost of production. So in this case, the firm would serve everyone in this market, and the firm would charge a price which is equal to K. So there is no distortion. Everyone should be served, and everyone is served in this market. But the firm has a profit of K. So in this case, the regret is just from the redistribution objective. So my regret is 1 minus 5 times K. I suffer because I don't want the firm to get a profit. I actually wish the firm is charging a price of 0 here. Right? So the lower my price cap is, the better I feel. The lower my regret is. Okay. Now let's look at the other situation. So everyone is still valuing this good at V upper bar, but there is, the price cap is at K, but there is a cost of developing this vaccine, which is equal to K, or maybe K plus epsilon. Okay. Now your regulation just to push this firm out of the market. He would not participate because the cost is too high relative to the price cap. So the distortion is equal to the surplus that could have been generated, which is V upper bar minus the cost K. The firm's profit is equal to 0. So in this case, the lower my price cap is, the worse I feel, the higher my regret is. Now you can see the trade-off between protecting consumer surplus and not inducing too much underproduction. So there is a value price cap K such that these two terms are equal. So we use K phi to represent this price cap. And this price cap is equal to V upper bar over 2 minus phi, is increasing in phi. And we're going to show that no matter how you choose your regulation policy, your regret is at least a 1 minus phi times K phi. Right? This is very intuitive, right? If your policy ever give more than K phi to the firm, then you lose this much from firm's profit. If it gives less than K phi to the firm, you lose this much due to the firm's underproduction. Okay. Now this picture shows the value of K phi, the price cap. The price cap should be half V bar when you only care about consumer surplus. It should be equal to V upper bar when you care about the efficiency. Right? If you care about the efficiency, you don't want to impose a price cap at all because you don't worry about redistribution at all. Now the lower bound on this worst case regret here is given by this blue curve. Okay. So the worst case regret is at least this much. With this intuition, now we can prove a tight lower bound for our regulator. Now this theorem says that pick any Q and P. Now the worst case regret is at least this lower bound of as a function of QP. This function lower bound is the minimum of two terms. The first term is roughly the regret from underproduction. The second term is roughly the regret from overproduction. Right? So if the firm, if the regulator constrain the revenue too much, he would lose from underproduction. If he offers to subsidize a lot, he would lose from overproduction. So this holds for every QP. So the worst case regret is at least the maximum of this lower bound function across all the Q and all the P in this market. Okay. Now you don't have to pay much attention to the algebra. I would just illustrate where this lower bound function comes from. Okay. So this lower bound function is given by this particular demand function. This demand function is likely to induce underproduction when the regulator is not when the firm is not regulated. So in this market, the first Q consumers have the highest value V upper bar. Now, starting from Q, the Q's consumer has the valuation P, and starting from this QP, we have unit elastic demand. So if the firm is unregulated, he would never go beyond Q. Right? So producing below Q gives him a higher revenue and also a lower cost. Right? Now, given this demand function, pick any policy role, we can ask what is the highest revenue the firm can get if he chooses a price quantity pair in this gray area, which is given by X. And we use Y to represent the highest revenue the firm can get if he chooses a price quantity pair in this blue area. Okay. So this X, Y, we're going to talk about the 3 different cases with respect to X, Y's valuation. The first case is that the regulator is so concerned about the redistribution, he actually says that the maximum of X, Y is smaller than Q times K phi. So you are not going to get a lot of revenue from the market. So in this case, if this firm happens to have a fixed cost of K phi, this firm would not produce, right? So if my policy is too tough towards the firm, and the firm happens to have a high fixed cost, the firm would not produce at all. Now, the regret I have in this market is the total surplus that could have been generated, which is the area of the gray area, the blue area minus the fixed cost. This is the first term in our lower bound function. So you constrain the revenue too much, you discourage production. Okay. Now, in the second case, the maximum of X, Y is higher than Q times K phi, but X is greater than Y. So this is a case in which your policy does not incentivize production beyond Q that much. So the firm would choose, if the firm does not have any cost of production, it will choose a point in this area to get this X. Right? Now the regulator loses from two fronts. The first part is that the firm is not going to produce beyond Q. So the regulator would lose Y, this whole area of blue area, in terms of lost surplus. On top of that, the regulator is giving the firm too much profit. So the profit is actually equal to the X. If the firm doesn't have any cost, the firm would get a profit which is equal to X. And the regret in this case is also equal to the first term in our lower bound function. Right? So in other words, if producing this much gives me a higher revenue, I would not produce beyond Q. The firm gets profit, which hurts the regulator. And also the firm does not serve these consumers, which also hurts the regulator. Okay. Now, the only way for the firm to go beyond the Q is actually that Y is greater than X. So in this case, this means that the firm, so the maximum of XY is greater than Q times K phi, and Y is greater than X. This means that the firm is actually subsidizing a lot if the firm is choosing a point in this blue area. Now, there exists a Q prime, P prime such that the firm would get this profit, this revenue Y if he chooses this Q prime, P prime in the blue area. If we actually change the demand and the cost function such that the firm is actually facing this type of demand. So actually the demand is very, very low and the firm has a huge cost of production. Your subsidy would incentivize this firm to participate, right? So you want to solve the underproduction here by subsidizing the firm a lot if the firm chooses something in this blue area. Unfortunately, if the firm happens to be on the right, a firm on the right-hand side, this firm would participate and produce a lot. So the regret from this firm would be at least Q times K phi minus Q prime P prime, which is the second term on the right-hand side. Okay. So intuitively, either you give up this blue area, you suffer from underproduction, or you incentivize the firm to go beyond Q and you suffer from overproduction with respect to the other firm. So that is a tight lower bound we're going to use. And the theorem says that the worst case regret is at least the maximum of this lower bound function across all possible Q and all possible P. And this R phi is the worst case regret that we will show is tight. Okay, so this I phi now is this blue curve. Previously it was going down to 0, but now it's actually tilting up and is given by this blue curve. Any questions?
There was a question from Humberto who was just asking about phi could also be a parameter of uncertainty. I mean, could you say anything about the case where phi is also not known?
You mean the actually?
No.
The objective function of the regulator, phi, right? Is not.
I guess phi could be uncertain as well. If they came
So yeah, here we are not. Actually, I think what you are looking at maybe is a more complicated case in which the regulator itself is an agent, right? So he has also, you don't know his objective, and yeah, but we are looking at the case that the regulator himself knows exactly. Yeah. Yes. Thank you. Yeah. Okay. Now
I also have a short question, if I may, since you are on this slide. What if phi is greater than 1? In principle, you could care about monopolist more if you are sort of, you know, a captured regulator in principle. And you had this term 1 minus phi somewhere.
Yeah. Yes. Yes. So you are saying that actually. So this is actually also. If we think about the other, so that's the case. Actually, I want the firm to get a lot of profit, right? So that is a case in which, actually, I want all the surplus to go to the firm. So it's what I know is that the intuition here is quite different. So, but we haven't looked at that case exactly. What we have done is to. A long time ago, we actually checked the case what happens if phi is actually greater than 1. And if it's so much higher than 1, we know the optimal policy is a proportional tax. But so it's very different than this picture. But we should talk more about that offline.
Yeah, thank you.
Okay. So now, given this lower bound, we want to show that actually our policy indeed achieves this lower bound. So I'm going to talk about the two extreme payoff functions of the regulator. The first one is that phi is equal to 0. So we have shown that the worst case regret is at least half V bar. And we are going to establish that the price cap policy would achieve this half V bar in terms of worst case regret. The second one is when phi is equal to 1. So for everything in between, you have to trust me that we have a proof. Okay. So now suppose that phi is equal to 0. So the regulator cares only about the consumer surplus. So I want to prove that the worst case regret is at most R0 if the firm imposes a price cap of K0. So both R0 and K0 are equal to half V bar. So half V bar is the price cap we want to impose here. Now, so the proof is very simple. So pick any demand function we can think about. So this blue curve is the demand that the firm is facing. I suppose that the firm says that, okay, the price cap is too tough. I'm not going to produce at all. So the firm chooses not to participate. I want to argue that the maximum surplus that the regulator loses is at most half V bar. Okay. So now, first, let's look at consumers whose values are below half V bar. So for these consumers, the regulator is not losing more than half V bar per consumer. Right? And now let's look at the consumers whose valuations are above half V bar. The firm chooses not to produce. There is only one reason for that decision. The average cost of producing is above half V bar. Right? Because my price cap is half V bar, and I choose not to produce. The only reason is that the cost of serving these consumers is more than half V bar per consumer. So that means the social surplus that I lose is actually this small triangle. So this is not more than half V bar per consumer. So this shows that my regret is at most half V bar. Now, let's look at a different case. I still impose this price cap, but the firm says, okay, I'm willing to produce a certain amount of Q. Okay, for all the consumers below, above Q, the same logic applies below as before. I don't lose more than half V bar per consumer, but for consumers below Q, I only lose, in terms of consumer surplus, a price P per consumer. But this price P is smaller than half V bar. So I also don't lose more than half V bar. Okay. So this shows how the price cap at half V bar would prevent the regulator to get more than half V bar in terms of regret. Okay. Now let's look at the other extreme. What happens if phi is equal to 1? Okay, so in this case, the regulator's payoff is consumer surplus plus firm's profit. So this is a regulator who is concerned about efficiency. So he doesn't care about the redistribution at all. Okay. Now we're going to first offer some intuition here to show how we can prevent the regret to be higher than R1. So the worst case regret is at most R1 given this policy. So this policy is the minimum of 2 terms. If the firm prices below V upper bar, I will tell the firm that I will subsidize you for the difference between your price and the V upper bar. So this effectively tells the firm that your price is V upper bar. Okay, this would encourage the firm to produce more than the firm would like without the regulation. On the other hand, I tell the firm that given this policy, I also want to have a constraint. The total surplus I will give you is not more than R1. Okay, so this is the piece rate subsidy we were talking about before, and this is the cap on the total subsidy I'm willing to give. Okay. We want to argue that if we choose R1 here, the worst case regret is at most R1. Okay, so let's look at let's first look at some demand function which is likely to induce underproduction. So this is a demand function we have seen before. The first few consumers have very high valuation for the product. Starting from this kink, we have unit elastic demand. Okay. If the regulator doesn't intervene, the firm would just serve these first few consumers. And the regret would be the whole area of this blue area, which is huge, right? So I'm suffering a lot because this firm is only serving Bill Gates in the market, only serving those people who have a very, very high valuation for the product. Okay, so I'm telling the firm, if you go beyond this point, if you choose Q and you choose price P, I would subsidize you for the difference between your price and the V upper bar. So this firm for sure would go to this Q point, and my regret would shrink to this blue area. Right? So I don't care about the redistribution. So I only want the firm to be as close to 1 as possible. So now my regret would shrink to this area. However, if I'm offering this subsidy, it's possible that the firm is not facing this demand function. The firm actually faces a demand such that the first Q consumers have a valuation P, and the firm has a cost of this whole area. So in that case, I would induce overproduction, and my regret is this gray area. So this is like when I want to induce some environmental technology-oriented firms to participate, and I subsidize them, I might invite some lemons to participate, and I would lose because I subsidize them, I induce overproduction. So this R1 is chosen such that this blue area is equal to this gray area. That's when overproduction and underproduction are balanced. So I don't have much time to talk about detail. The very quick intuition of saying that this type of subsidy is optimal is the following. We ask ourselves the following question. If an unregulated firm sells Q units at the price P and it doesn't want to produce more, how much additional surplus we will lose as a regulator? So the result is given by this lemma is exactly this area. So that's why we are choosing unit elastic demand throughout the talk to illustrate the intuition, because the maximum surplus I can lose is exactly given by this unit elastic demand. And we can choose this point to balance these two. Okay, so that is what happens when the firm is solely concerned about efficiency. Combining what we have for phi being 0 and phi being 1, the worst case regret is at most I phi given the following policy. So we just change this price from V upper bar to K phi. So this policy has 3 elements. The first element is that the firm is not going to get more than K phi per unit, right? Because the rho Q phi is the minimum of these two. So you are not going to get more than K phi. That is a price cap. So that makes sure that the firm does not extract too much surplus from the consumers. The second element is that if the firm actually prices below this K5, I would subsidize him for the difference between his price and this K5. The main idea is that I want to encourage the firm to go beyond consumers like Bill Gates. I want the firm, if the firm charges a very low price and serves a very high quantity, I want to reward this firm by subsidizing the firm. The third element is that the total subsidy the firm can get should not be more than S. Okay, so I don't want to subsidize a lot because I worry about inducing overproduction. So these three instruments, we show that to some extent they are necessary. This theorem shows that they are sufficient. So if I'm a regulator in an environment without a prior, these are exactly the three instruments I should choose. Price cap, piece rate subsidy instead of lump sum subsidy, and cap on the total subsidy I'm willing to offer. Okay, so this is the main result. Now, we actually have 9 minutes, so I have some time to talk about the extension. Any questions so far for the main theorem? Okay, so in the extension, what we are going to talk about is how we incorporate additional knowledge about the demand and the cost. Right? So far, we have made the assumption that the regulator doesn't know anything except that the consumer's value is above 0 and below V upper bar. So in reality, you can imagine that the regulator has some knowledge about the cost function, or it has some knowledge about the demand function of the firm. So in this case, we can extend our analysis very easily to this environment. All we need to do is to actually incorporate the knowledge in this set, capital E. Right? So we choose a policy to minimize the worst case regret, and the worst case regret is calculated across all the demand and the cost function that is in this set E. Right? So as we change E, as we make the E smaller, the worst case regret is going to be smaller as well. Right? So now we were looking at the two different sets of E to illustrate how to extend our analysis to incorporate additional information about demand and cost. So the first one is additional information about the cost function. So very frequently, the regulator may know that the cost function actually takes the form of a fixed cost plus some constant marginal cost. So CQ is equal to A plus B times Q. But the regulator doesn't know the exact level of this A and B. Right? So this is more restrictive than our baseline framework. However, if this is the knowledge that the regulator has, we show that our lower bound theorem still holds, because in that proof, we only use fixed cost functions. So as long as we don't know the level of fixed cost, even if I know that you only have a fixed cost, I still have that lower bound on my worst case regret. This means that our policy is still optimal, even with this additional information. Of course, if we can bound the value of the fixed cost, we can do better. But here is just to show that without knowing the level of fixed cost, we cannot do much better. The second addition information we want to talk about is additional information about the demand. Suppose that the regulator knows that the demand actually has an upper bound of V upper bar, and also it has a lower bound of V lower bar, right? So suppose it's about housing, vaccine. I know that everyone's valuation is at least a V lower bar. Okay. Now we can adjust this V upper bar and V lower bar. As they get closer, the consumers are more homogeneous. As they get wider, the consumers potentially are more heterogeneous. Okay. So in this case, we can show that if the firm cares a lot about the consumer surplus, so phi is smaller than 1/2, everything stays the same. So this information doesn't make regulators' life much easier than before. The basic intuition is that if phi is very small, the regulator mainly concerned about the redistribution and efficiency, right? So the trade-off is between underproduction and protecting consumer surplus. So this lower bar doesn't make regulators' worst case regret smaller. But if phi is equal to 1, the regulator cares about efficiency, then this information is very valuable. If I know V is very close to V upper bar, I essentially know the demand function. I can make sure that the firm gets enough revenue so that the firm doesn't underproduce. So this picture shows the worst case regret as we increase V lower bar from 0 to V upper bar. My worst case regret would decrease from R1, which we have seen before, essentially to 0, right? So if I know exactly demand function and I care about efficiency, I would always achieve 0 regret. Okay, so this shows that efficiency-oriented regulator actually has every incentive to learn more about the demand function. Okay. Another thing we get from a question?
Yeah, I was wondering, do you know what the smallest set of B and C would be such that you still get your main result?
The smallest.
Or is there? I'm not sure if there'll be the smallest, but you could think about, because your argument relies on only certain B and looking at certain B and C, so you might have a sense.
I see. That's a very good question. So for the cost function, I think we can. It's good to restrict attention to this type of fixed cost plus constant marginal cost. We can find an upper bound on the fixed cost. So if you know it's between 0 and this upper bound, then our result still holds. So that's what we can do. Okay. For the demand function, now you can see that as long as we know V lower bar for any phi smaller than 1/2, then no matter how you change this demand region, you still get the same result. So that's another, so even if you know exactly the demand function, you still get a lot of regret if you care about the consumer surplus. So that can be viewed as the lowest demand function region we can think about. Right. So for phi greater than 1, as you can see here, if V lower bar is smaller than this value, our result still holds. But if it's above, then the regret is getting smaller. So this roughly would give you an idea of how to shift this box to still get our result. But that's a very good question. Thank you, Danny. Yeah. So the other thing we have about this incorporating demand information is this more general price cap optimality. So previously we say that when phi is equal to 0, price cap is optimal. But here we can extend it to phi being small, but not necessarily 0. So if V lower bar is greater than this value, then it's optimal to impose a price cap. Intuitively, when the consumers are relatively homogeneous, you don't worry about underproduction too much. You don't worry that the firm would just serve Bill Gates, because other consumers' valuation are also close to Bill Gates' valuation. So you don't worry about the firm just serve a few very rich people. So in this case, you are mainly concerned about firms extracting too much surplus. So it's optimal to impose a price cap. So homogeneous consumers, price cap is optimal. So that's the main result for this proposition. Okay, so in the end, I want to go back to Daniel's question at the beginning. So why we are choosing this worst case regret as our approach to uncertainty. So I have said before, we are choosing worst case regret over a Bayesian approach, mainly for 2 reasons. The first reason is that in many situations, information asymmetry is very pronounced, so it's not clear how to form a prior. The second reason is that multidimensional screening under Bayesian approach is very, very difficult to solve. So in our framework, we are able to solve for the optimal policy, to identify which instruments are necessary and sufficient for optimality. Now, among all the non-Bayesian approach, so we are choosing this worst case regret approach for 3 reasons. The first one is that the regret has a very natural interpretation in our framework. It's a weighted sum of efficiency objective and the redistribution objective. The second reason is mainly about why we are not choosing worst case payoff. Right? So in this framework, the regulator's worst case payoff is always zero. So if their consumers don't value the product too much and the cost of production is very high, there is no surplus in this market at all. Right? So if there is no surplus, there is nothing the regulator can do. So we argue that the regulator's job should be to protecting a surplus when there is surplus to be protected. So the worst case regret captures this idea. Right? So you want to protect the surplus when there is surplus on the table to be protected. The last motivation is this group decision motivation offered by Savage. So this is a quote from Linhart and Radner, and I just changed a few words to make it to fit in our setting. So suppose that the regulator must justify its policy for a group of persons who have very different subjective probability distributions. In this case, the regulator might want to regulate in such a way as to minimize the maximum outrage felt in the group. Here, the outrage is equal to the regret. Right? So that's kind of the group decision justification. So what we learn from this framework, I think is very simple, but it's also very powerful. So this worst case regret approach allow us to identify 3 objectives by the regulator. He wants more surplus for consumers. He wants to control underproduction. He wants to control overproduction. Also, we identify 3 instruments for each objective. Right? So price cap is for delivering more surplus for consumers. Piece rate subsidy is to mitigate underproduction. And the cap on the total subsidy is to mitigate overproduction. Okay. So I'm 2 minutes late, and this is the end of the talk. And thank you for your attention. Yeah.
Okay, thank you very much, Yingni, for a really interesting talk. So now we can ask our guest panelists whether they want to make comments or ask questions, and then we can answer questions from for everyone else. So I don't know whether Daniel or Derek have any comments or questions.
Thank you, everyone, again.
No, I think that was a great talk. In the end, when you talked about extensions, I would have thought that one of the first ones would be to narrow down the uncertainty and think how much you can improve if you have uncertainty only about the demand or only about the cost side. That would sort of allow you to isolate the different sources and maybe quantify a little bit of which side of the uncertainty is sort of more relevant.
Uncertainty, yes.
And I guess, right, so regret is defined with respect to what you done optimally if you had full information. So you could also ask, when will the regret minimizer as a regulator behave most differently from a Bayesian regulator? That I think would help me understand a little bit more the differences and the change in perspective that comes with regret.
Yes. So for this question, actually, if we think about the Barry and Meyerson framework, right? So that's there is only cost uncertainty. So in that case, so this Bayesian literature, they don't approach this question from the perspective of instruments. So what type of regulation instrument we are using? So they mainly ask, okay, if the firm reports its private information and we assign a quantity and a price for the firm. So if we think about the Barry and Meyerson, the basic takeaway in that framework is saying that most productive firm, so the least costly firm would produce the efficient level. They would get some rent, and as we increase the cost, we will distort the production so that we can reduce the rent that we are giving to the most productive firm. So that's kind of the, it's in general the takeaway from that type of literature, if I understand correctly. Yeah. So for our framework, it's the angle is a little bit different.
Can I perhaps follow up on that question. So one thing you may wonder is whether there exists a distribution of V and C such that the optimal row would lead to the same payoff. So at the moment, the principle offers rho, and you can think of nature responding to rho by choosing the worst V and C. But if there was a distribution of V and C, you could reverse the min and the max. But there's a question: if you had a random, if you had a distribution of V and C, does there exist a worst case distribution against which, even though the rho is chosen optimally, but this yields the same payoff as in the problem?
I see. So So the alternative framework we can think about is that there is a set of distributions over B and C. So in that case, I choose a policy and I look at a policy that minimizes the worst case expected regret I can have across the distribution. Right. So we are looking at the extreme, right? So we're looking at, actually there are many degenerate distributions and what happens. So if you allow for other distributions, it would still, I imagine that if we incorporate all the degenerate distributions, we would still have the same result. But I guess the combination of these two is a direction to go. It's basically a combination of worst case regret and Bayesian approach. Did I understand correctly, Daniel?
Right. I guess it's just a question about whether, although you're in this kind of complicated environment, we don't necessarily expect a minimax theorem to apply, but nonetheless, the implication of minimax results may turn out to be true in this setting, and that is what sort of motivates me to think: could there be a distribution over B and C such that if I pick rho optimally given this distribution, then in fact I get the same payoff.
I see.
Right. So this is, you might reasonably think that perhaps the distribution would be over the same set of V and C that you need to look at, the smallest set of V and C that you need to look at.
Yes. So that's actually there is another point I want to make is here. That's a very good point. So it's actually related to both what you have said and what Dirk has said, is in terms of a comparison to the Bayesian approach, right? So this second paper by Lewis and Sappington and this paper by Armstrong, they assume that there is both uncertainty about the cost and the demand. So in their framework, they actually find that there is overproduction as well under the optimal policy. So if we just look at Barron and Myers and Lewis Sappington, the first paper, they only have one-dimensional uncertainty. They don't have overproduction at all in the optimal policy. But if you allow for uncertainty of both demand and cost, they find that under the optimal policy, there is a trade-off among the three objectives we have identified. But it's very, very hard to say, to carry out so it's very untractable. So basically they illustrate that by examples. So that, going back to your question, yeah, I think we can think about whether there is kind of a distribution along the line of their papers, which shows that it gives us the same worst case expected regret, something like that.
Okay, so I just sent a message. So if somebody from the other panelists wants to make a comment or question, or somebody from the audience, I can unmute them and have a question live.
So I have one more question. So sometimes when people look at regret, it's because they anticipate at some point in the future the information is going to become available. So if the regulator at some point is going to learn V and C, or in this last quote that you gave, the public is going to learn what V and C was, and then they're going to be outraged because they know what the solution was. So I guess in these regulatory examples, maybe I'm not sure whether we think, like from a practical perspective, whether that is the right setting. But it was something that motivated a bit. As I understood it, as I tell my students, that the Lafont-Tirol approach was to say, one possible criticism of the Baron-Meyerson framework was that the cost information might come out later, and then the regulator could use that and penalize the firm if it misreported as cost information. And so the Lafont-Tirol setting was a way of keeping that information hidden because it was about effort, and that your cost of effort would never really be known, perhaps. So there seems, so this at least is an issue which is interesting.
Yes, that's actually it gives me a chance to advertise for the, so Aaron and I were actually working on the second project, right? So it's actually related to what you said about the Lafont-Tirol, right? So what happens actually if you have evidence about the cost or demand function you have? So we're actually working on how to combine worst case regret with evidence, right? So you can report, and for some evidence is verifiable. We're not looking at this, so for that case, we're not looking at it in the framework of Lafont-Tirol, but the general question is about how to incorporate evidence in this worst case regret approach. So hopefully, yeah, we're still working on that, and it's actually also a good framework to explore what worst case regret can teach us, because it's a framework of multidimensional private information, and it's extremely hard to say anything about that problem in a Bayesian framework, right? So we can only work on like a very simple, small examples using Bayesian framework. So on top of what you have said about this group decision motivation, like the political economy motivation, right? So if I'm a regulator, the other thing I think I didn't mention about it is the other motivation for us to say is mainly what we can say about this problem. Right? So if we face a very difficult decision problem under uncertainty and Bayesian doesn't tell us much, we hope to motivate us through what we have learned in this approach. Right? So you can see this approach teaches us a lot about the trade-off and the instrument in this regulation. So that's more like from a practical perspective, we can tell the regulator exactly like these are if you are using lump sum transfer, it has the danger of inducing overproduction without incentivizing the firm to conquer underproduction. So if you use price cap, it's actually a very good policy if you think that people have homogeneous value for the good. So we also want to motivate from the practical discussion with the regulator.
I have one more question from me. So, have you also thought about the motivating in terms of ambiguity? So you have some beliefs. So the worst case scenario would be like a max min with all of the possible distributions over the state space, which is sort of the uncertainty that you have. But then you can go and have other decision models.
Yes. So we have so in this case you can think about this as kind of allowing for all types of distributions you can think about, and then the degenerate ones pin down the policy. But I think that falls in the same line of research direction, right? So what happens if we can narrow down the set of demand and cost distributions we can think about. So we haven't done that much, and we look forward to expand in that direction.
Okay. Any other questions from?
I had. It's more of a comment rather than a question, which is, of course, regulating monopoly is one of the 2 or 3 most important applications of asymmetric information economics. And one thing I've noticed is that because you're making policy prescriptions in a way, you're making, and one of the things that this is a model that's very static. There isn't innovation at all in the model. And for example, very basic intuition suggests that price caps and so on. I mean, I wonder whether you've thought about dynamics at all.
I see. So it's actually, yes, I see. So you're saying that by dynamics, are you saying that the V and the C can change?
Yeah, I'm specifically the C. Well, the V can change, of course, but you know, in Italy, for example, there's been a huge polemic about face masks because there's the government decided to put a price cap on them, and a lot of people are finding it very difficult to. Now, I'm not saying the government is doing optimal regulation here, but one of the things many people have said is that there are a lot of firms who have never produced face masks who might be willing to produce face masks if the price was sufficiently high. So there is an argument that's been made that there is undersupply right now simply because they haven't taken into account the dynamic aspect of this.
Yes.
That's just the first example that came to my mind. So I'm thinking more of a cost function changing over time, innovation, and things like that.
Yeah. So this actually, if you think about the face mask, right? So actually, I before this project, I never saw the price cap to be a good policy, right? So if you think about rent control, I never thought of it because it discouraged landlords from investment in the property. But if you actually, what you just said exactly mirrors the concern we actually illustrate in the paper, right? So you don't want the firms to charge 1,000. So at some point on Amazon, each face mask, like 10 face masks, is like $200. You don't want them to charge this price to take advantage of this situation to extract surplus, because they know the demand is very high. But on the other hand, if you put a price cap, you definitely discourage a group of firms which should have produced from participating. So there is no perfect remedy for this, but at least we can, in this situation, right? So we can say, okay, if you care about the consumer surplus sufficiently enough, actually price cap is not a terrible policy in this case. It's actually, in our framework, is optimal. So the other thing you talk about is dynamic. So for the dynamic instrument, I think dynamics actually favors our framework. So one thing is what you have said, right? So if we enter the pandemic, the production, the valuation for the cost for the mask would change quite a lot, right? So from today to tomorrow, the valuation function V is very different. This actually shows that it's like what Dirk and Kyle wrote in their paper. There is a first time, right? So you don't know exactly how to formulate a prior belief over people's demand for the face mask. So this actually favors the worst case regret approach. The other thing I want to mention is my discussion with my colleague, Ma Regent. So she works on the electricity industry of Spain, and she found out that the demand for the emission permission actually changes very, very dramatically from this year to the next year. So in some years, the demand for the permission permit is very high, the price is quite high, and for some years it's very low, the price is literally close to zero. So if you think about dynamics, I think it favors worst case regret more, because it's very hard for the regulation, to formulate the priors.
Thank you, Yingyi.
Thank you. Yeah.
Okay. Any other questions or comments?
I have a small one, or basically, it's actually more whether she has thought of the connection of this analysis, okay, with this old analysis about this old analysis in the social choice literature that said that basically in general exchange economies, if you allow for general preferences and you look for dominant strategy incentive compatibility, the only mechanism that is dominant strategy incentive compatible is basically posted prices.
I see. So that's actually related to the earlier discussion we had, right? So here we are actually looking at the case that the firm is just it's essentially just posting a price, right? So of course, but for the regulator, I think what you are saying is like if you zoom out the interaction between the firm and the consumer, the only thing that the firm can do is posting a price. So that's exactly how we are modeling here.
Well, I was just thinking of the problem of how to design a bilateral trade protocol, okay, when the buyer and the seller have general preferences and you're interested in dominant strategy incentive compatibility. Okay, and in that literature, okay, it's an old literature where basically what they showed is that the only mechanism or the only set of mechanisms that are basically dominant strategy incentive compatible in that setting, if you allow for a sufficiently general set of preferences and cost functions, okay, it's basically posted prices. Okay, this goes back to an old paper by Barbera and Jackson in, I think, Econometrica 1995.
So I think if we combine what we have today from that, that's basically offering. If you are saying that we can look at the regulation environment such that the firm and the consumers they are playing a kind of posted price game, and this is the only dominant strategy proof mechanism we're thinking about. So I haven't thought about like how to incorporate that to the game, incorporating regulator. But that's actually a good motivation for why we are focusing on the posted price mechanism for the firm. But going forward, I think we should also explore what happens if we look at the Musa-Rosen framework, which would allow firm to post bundles instead of just the price. Yeah.
Thank you.
Okay, thank you very much, Yingni, and for our guest panelists and for everyone who participated. Hopefully, we'll see many of you next week, and have a good day.
Thank you very much. Thank you, Dirk.